All right, what's up, everyone? Can you hear me all right? I haven't done one of these live streams in a couple months. So if you're in the chat, just let me know if you can hear me. If not, say something and I'll try to fix it. Today is going to be pretty interesting. Well, before I begin, just let me know if you can hear me. Someone give me a thumbs up. Someone? Anyone? We got Destin, Human in here, Iced Earth. We've got 16 people watching. All right, I'm going to start in a couple seconds. All right, I'm going to start. So, what I'm going to walk through today is a little bit about the infrastructure behind hate5six. A lot of the more discussion about some of the tech that's like behind the scenes here. Obviously, what you see is just the videos on the site, but I also maintain a lot of servers in my apartment that keep everything running. So one of the issues that I have is basically I have everything that I've ever filmed saved on hard drives. And so there's different ways you can do it. You could basically buy a bunch of external hard drives and put all your footage on these things and hope that these don't break. Or you can be a little bit smarter and use something called a RAID array, which is something I'll talk about too. I'll talk about that a little bit today. Basically, everything that I've filmed over the last 10 years is close to 40-some terabytes, so it's a lot of video, and it's growing pretty rapidly. It's more than I can actually host reasonably on like the cloud. Just given the cost of maintaining everything on the cloud, it's actually cheaper for me to build my own servers and maintain them myself, at least for now. So, like I said, the issue with having everything on hard drives like this is that if all of my data is on one of these hard drives and this thing dies, then I'm fucked. One way around this is by buying multiple hard drives. So I could have two of these. Here's like another one. You can imagine I have, let's say this is 40 terabytes. I could put everything on here. And if I want to be safe about it, I can buy another set of 40 terabytes and mirror everything. But that's really not that cost effective. One, because I'm buying 80 terabytes worth of storage and I'm only using 40 terabytes effectively. So I'm using something called a RAID array. RAID stands for Redundant Array of Independent or Inexpensive Disks. And it's basically a way of having multiple hard drives work together in unison in such a way that the data is distributed across all of the drives. And what's even better about it is because the data is distributed in a smart way, and there's different levels of RAID. You can actually have, you can protect against a different number of drive failures, but essentially, depending on the RAID level that you're running, you can sustain up to several hard drive failures concurrently. And so what that means is your data is distributed across these disks, and if a hard drive dies, you don't lose anything. Basically, as long as you replace the drive, the surviving drives can work together and figure out what data was actually on that dead drive. And once that dead drive is replaced with a new one, the surviving drives can work together and repopulate the array and basically tell the new drive all the data that it should have. So that's really high level. I'll go through a little bit of a walkthrough. Actually, let's just do it right now. So this is essentially when I'm talking about RAID, this is essentially what I mean. So as you may or may not know, information on a computer is stored as a series of zeros and ones. And so let's say we have, so even like a video file, the stuff that I'm storing is just a sequence of zeros and ones that I'm storing on the hard drive. So one thing so here's kind of like a high level of what RAID is doing. So because we're dealing with zeros and ones, there are, well, let's say we have a file with 2 bits. So the types, the combinations of zeros and ones that it can take are either 00, 01, 10, or 11. So in this case, so what I have here on the spreadsheet is basically all the possible combinations of zeros and ones for a file that has 2 bits. So let's just say that I have this file and I'm storing. I'm doing something called striping. I'm basically putting half of the bits on this drive and half of the bits on this drive. So if the bits for the file are 0, 0, what you would do is what RAID would do is it would put the first 0 on drive 1 and then the second 0 on drive 2. And so basically each of these rows is the different combinations that you can have of zeros and ones. So again, just as an example, let's say the file is 1, 0. What RAID would do, it would put the value of 1 on one of the drives and the value of 0 on the other drive. And if we have a third drive, what we can do is we can basically put a sanity check here. And you can think of a sanity check as being like it's maintaining the consistency or the parity of the information spread across the other disks. And so essentially, I don't want to dive into too much computer science jargon because I don't know what the background is of everyone who's watching this. But let's just say the third drive in the array is just storing the parity. So there's different operations that you can do on bits. So let's just say so one common operation is called. Actually, I'll just go through all the different operations that you can do on bits, or at least some of them. So OR essentially says, given 2 bits, if one of the bits is 1, then the value for OR is 1. So it's essentially saying you can think of the zeros and ones as a truth table, 0 being false, 1 being true. OR is saying if at least one of the bits is true, then my value is true. So in this case, since both bits are 0, OR would be 0. In the second case, if the bits are 0 and 1, 0 or 1 is 1. Similarly, in the next case, 1 or 0 is 1. And in the last case, 1 or 1 is also 1. And is another logic gate that you can apply on bits, and it's different from OR in that both of the bits have to be true, or both of them have to be 1 in order for AND to be 1. So in this case, if it's 0 and 0, the value for AND is 0. If it's 0 and 1, the value for AND is 0. If it's 1 and 0, it's going to be 0. And if the values for the 2 bits are 1 and 1, then the value for AND is 1. Now, so let's just say that this hard drive dies. So again, what we have here is this is drive 1, this is drive 2, and we've distributed our data across these 2 drives. So if this hard drive dies, then what we have here is we're just saying that this is all gone. So the question now is, can we use either of the, and again, so what I'm demonstrating here is that the third hard drive that I have, let's say this one here, is going to be storing the parity. And again, the parity is a sanity check. So if this hard drive dies, we have technically this one and this remaining one left. Now, what RAID is trying to do is it says, okay, drive 2 died. Can I use the surviving drive and the backup parity drive to rebuild or figure out what was on that drive that just died? So we can try reversing that logic that we applied to see if we can recover what's on drive 2. So if we know that, so in this case, we know what the value on drive 1 is, and we know what the value of the OR gate is. So in this case, we know that 0 or something is 0. And so again, in order for OR to be true, one of the bits has to be true. So because OR is 0 and drive 1 is 0, we know necessarily drive 2 in this case must be 0. Now, this is where we're going to start running into a problem in a second. So in the other case, if the value of OR is 1 and the value of the drive 1 bit is 0, we know that drive 2 necessarily must be 1 in order for the OR gate to evaluate to 1. Now, this is where we run into the problem. So in the next two cases, we know that drive 1 has a bit value of 1, and the OR gate evaluates to 1 as well. This doesn't actually answer the question, because in either case, if drive 2 is 0 or 1, this OR gate is actually going to evaluate to 1. So OR is not a good way of keeping track of your parity. Similarly with AND, you're going to have the same problem with AND. So if we know that AND is 0, we know that at least one of the, well, again, let me back up. If we go down to this case with AND being 1, we know that the variables on both drives 1 and 2 must also be 1. So in this case, this has to be 1. In the remaining cases where AND is 0, we actually don't know if this is 0 or 1, 0, 1 or 0, 1, because these will always evaluate to, actually no, we know that this one will be 0. In the case where AND is 0 and we know that drive 1 is 0, we don't actually know whether drive 2 is 0 or 1. So really quickly, we've just shown that ORs and ANDs are not good operations to apply on bits to figure out what the parity of all the data is. So we can do something else that actually will help us answer this question. So we can do something called exclusive OR. Exclusive OR, or it's also called XOR, is similar to OR, but the only difference is only at most one of the bits has to be true. So if both of them are 0, then it's 0. If both of them are 1, then it's 0. The only time it's 1 is if only one of the bits is 1. So in this case, we're going to have, we'll just do this. So if we evaluate XOR here, 0 XOR 0 is 0 because they're both 0. In the next two cases, XOR evaluates to 1 because only one of these bits is 1. And in this last case, because both of the bits are 1, XOR is actually 0. So again, let's see what happens when we have this problem where drive 2 dies and we need to recover the data on drive 2. So if we know that XOR is 0 and we know that drive 1 is 0, this must necessarily be 0. Similarly, well, actually, in the second case, if XOR is 1 and we know that drive 1 is 0, the only way that XOR can evaluate to 1 in this case is if drive 2 is 1. On the flip side, if XOR is 1 and drive 1 is 1, then we know drive 2 must be 0. And again, that's because exclusive OR says at most one of the bits has to be true, and has to be true in order for XOR to evaluate to 1. Now, the case here, if we know that XOR is 0 and we know that drive 1 is 1, the only way that XOR can evaluate to 0 is if this is 1. So essentially here, what I've just showed you is that we can reserve a hard drive to basically store the value of taking 2 bits and taking the value of exclusive OR between them. So RAID is a little bit more complicated because you can have different levels of RAID. You can have RAID that I'm running a version of RAID called Z3, which should allow me up to 3 hard drive failures. And I think there's RAID 0, RAID 1, RAID 5, RAID 10, there's all different kinds of RAID. And it just depends on how much space you're willing to allocate to store these parity bits. So here, actually, I'll show you what my RAID array looks like. This is a picture of my array. I'll show it to you live in a second, but this big ass thing down here is my RAID array. Each of these bays, these brown and yellow things, is a slot, and they are each holding 4 terabyte drives. So I have 16 of them. I think it's these 2 columns and then these last 4 here. 1, 2, 3, 4, 5, 6. Yeah, it's these 2 are all full of hard drives, and then these 1, 2, 3, 4 they are full of 4 terabyte hard drives. And again, this is running in a RAID Z3 configuration, so it's technically a 52 terabyte array, but because I'm reserving essentially 3 hard drives as the parity check, I only have maybe like 40 some terabytes worth of usable storage. Again, and that's because I'm using a lot of that space just to protect against hard drive failure. So RAID is good for redundancy, and that's why it's called a redundant array of independent or inexpensive disks, because it's a way of protecting you against multiple hard drive failures. So I've had this array since fall of 2015. Unfortunately, one of the drives died, but that's not the end of the world because I can still actually access the data on there. So I'll show it to you. So this is the array. Right now, this is everything that I've filmed over the last 10 years. It's just pulling off this server right now. So I don't know, here's like every gouge away video I filmed. Here's every power trip set. And it's all indexed by date. And so if I hit play here, whoops. Well, that's fine. There we go. So basically, you can think of it as just one massive hard drive that is protecting against hard drive failures. But again, everything's on here that I need, all the raw footage and all that good shit. So what I did recently was I built a second array, which is this top one here. So the bottom one, I'm using some open source software called FreeNAS, and I built this with my friend Steven, and we basically built the array from scratch, installed the software, configured it, and all that good stuff. This top one here is a Synology disk station. This one I've had for a couple years, but I basically replaced all of the hard drives. I had 3 terabyte hard drives in each of these 8 bays, and I replaced them with 10 terabytes. So this is running, I think, RAID 6, I think. So right now, I'll have a separate video about this, but this is basically, these are mirroring one another. And so what's going to happen is, probably within the next week or so, I'm going to take this top array, and I'm going to move it to my parents' house, which is in a different state. I'm going to put it in their basement. And what's going to happen is every night, my production server, which is this bottom one, it's going to automatically back up and sync with this offsite array. So RAID is really good for protecting, again, against hard drive failures or whatever, but having an offsite array is actually technically what a backup is, because if something were to happen to the entire array, if all the hard drives were to die, or if there were to be a fire, or something were to happen, if I were to lose this array in anything, any like type of fire or theft, at least I would have an identical backup in an offsite location. So this is why hate5six is fairly expensive to run, is because I'm trying to put in all the precautions and safety measures now to make sure that I'm not losing any of my data. All the data is backed up redundantly. It's stored offsite. At least with the raw footage, all of the edited stuff is available online, both on Vimeo and both on YouTube. So I'm taking the precautions now to make sure that I don't lose any data down the road. So let me walk you through exactly what happened. So this is the interface for the FreeNAS software, and what's going on here. So this will allow me to basically, I'll show you the volume here. So if I go to, so this is the hate5six volume. Again, this is what you're seeing here. This is just the massive array of everything that I filmed. And again, you can think of it as one big hard drive. Now, a couple weeks ago, I was getting this red alert here up top here, and this is basically saying that device /dev/DA4, it failed the smart self-check, backup data now. It says it has currently unreadable pending sectors. It's offline with uncorrectable sectors, blah, 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 blah. So it's basically warning me that my RAID array is in a degraded state because one or more devices are faulted in response to persistent errors. Sufficient replicas exist for the pool to continue functioning in a degraded state. So basically what that means is, again, in this array, I have 16 hard drives, but one of them died. But I didn't lose anything because I have redundancy built in. So this is the first time it's happened. I'm glad. Well, it sucks that it happened, but at least it's proof that it works and it's working as it should. So I'll show you a little bit more of the diagnostics that I'm running here. So if we go down to the shell, I don't know if you can actually see this, but I'm going to run a command called zpool status, which will show me the status of all the drives. And here we go. We can actually see that the fifth drive, so this is 1, 2, 3, 4, 5, its state is faulted. It has 5 read errors and 155 write errors. And there's too many, yeah, so there's something wrong with this drive. So what I'm gonna have to do is I'm gonna have to remove it. I have a brand new 4 terabyte drive. This is identical to the ones that I'm using. I got this online a couple days ago. It just arrived today. I am using these Western Digital 4 terabyte enterprise drives for my array. These are rated to work really well in this type of situation because if you think about it, all these hard drives are vibrating and spinning at the same time. So it's creating a lot of heat and it's creating a lot of vibration. So you need drives that are built up for that resiliency and that can handle that type of workload. You can't just throw in a random hard drive in there because these are not built to be running 24/7 and in close proximity with 16 other drives spinning as well. So because these enterprise drives have lasted me for 4 or 5 years now, I felt safe getting another one. So hopefully we'll be good to go. So we go here. I'll show you exactly some other stuff that's going on here. So we go to reporting. This just shows you this. Well, this basically displays what is going on under the hood with the array. So this is just showing the CPU usage. It's really not doing much CPU wise. It's only when I'm pulling video off of it, processing video, that it actually needs to use the CPU. But really, most of the stuff that's going on is reading and writing. So each of these graphs is showing the input and output, basically the read-write operations on each disk. So all of these disks are running well except for this one. So this is DA4. This is the one that died. So as you can see, for the last however many days or weeks, it's actually not been doing anything. So everything else looks like it's been running. So what's going to happen is, technically, I could pull the hard drive out now and just replace it. It's called like a hot swap. I theoretically shouldn't have to turn anything off, but just to be safe, I'm going to power it down, and I'm going to take the drive out, replace it, pop it back in there, and then it's going to go through this process, which is what I discussed in the spreadsheet. Basically, again, we're saying that that hard drive died, and in this example, I'm showing one hard drive, but in the real life case, I have 15 other drives that are surviving, and they're gonna have to work together to figure out, okay, what was actually on that drive that just died. So they're gonna have to use the parity bit, again, the value for exclusive OR, to figure out what was missing, and then it's gonna have to rebuild. So it's gonna take probably a couple hours for the drive to repopulate itself. Now, my concern is that it's very common during a rebuild for other drives to die, and that's because this is such a very computationally expensive task to run, for the hard drives to be communicating with the RAID controller and communicating with each other to figure out what data is missing, what this hard drive has, what this one has, what the value for the exclusive OR should be. So it's going to be really taxing on the array. So my only concern is, now that one drive has died, that I might lose other ones during this rebuild. But again, at the very least, I have this second array, this Synology disk station. This is up to date. This has everything. So in the event of this guy failing, at the very least, I have all of this stuff backed up on here, and I can again, if this dies, I can copy everything from the second backup back onto the production array. So before I turn anything off, I'm just gonna make sure that I actually have everything mirrored on the disk station. So let me just open both of these guys up. So FreeNAS, this is the production array, and backup is the Synology. So it's gonna take a second to open. All right. So I'm just checking to make sure that, so I have basically 2 directories in the production server and also in the backup server as well, volume 1 and volume 2. And the way I've decided to split it up is volume 1 is the first 10 years of hate5six, so everything that I filmed from 2007 till 2018. And then volume 2 is going to be 2019 and on. And the only reason for that is, so I mentioned that I have 16 of these slots are filled up with hard drives. So I technically have 8 slots left. And what I'm going to do is I'm going to take the 8. So again, this Synology disk station is full of 8 10 terabyte drives. And previously it was filled with 8 3 terabyte drives. So I'm going to take those remaining 3 terabyte drives, those 8 of them, and I'm going to put them in these remaining 8 slots. I'm not going to do it today. I'm going to do it in the next probably couple weeks, but they'll go in these last remaining slots, and I'll create a second volume. So basically, that second volume is going to be 2019 and on, and that should hopefully last me for a couple of years because that should be, I don't know. We can actually there's actually a disk station calculator. So I'll just show you what that looks like. Calculator. So, like I said, I'm going to take 8 3 terabyte drives. So 1, 2, 3, 4, 5, 6, 7, 8. I don't know. It's not letting me put 8 in here. I don't know why. Anyway, so what this calculator allows you to, it shows you basically how much usable space you have. So if you're using RAID 0, so again, RAID 0 is just putting everything on one hard drive. So if I take 7 3 terabyte drives, that's 21 terabytes. But the problem there is if one of these hard drives dies, then I lose everything on that drive. So again, that's not ideal. So RAID 1 will basically give me 3 terabytes of usable space and 18 terabytes of protection, and that's not ideal because I'm wasting a lot of space for protection. But so there's different levels you can choose. I think for my case, I'll probably run RAID 5 or 6. RAID, again, this is with 7, so with 8 terabytes, or with 8 drives, it'll probably give me maybe 17, 18 terabytes of usable space. So that should last me for a couple years on volume 2, ideally. So what I'm going to do is I want to check to make sure that these are identical, and we are. Yep, so we have 177 gigs on volume 2 between the 2 arrays. So I'm convinced that this is all up to date. Actually, what I have here is, let me see if this will show you. So under tasks, rsync tasks, here we go. So I'm actually using something called rsync. So basically and this is basically the configuration for it, but let's see. Yeah, every day at midnight, at 12:01 a.m. every morning, I'm running this rsync command. So even if I'm not awake or if I'm not here, rsync is basically a tool that will allow you to copy files from one server to another. So I set up a job that runs every morning at 12:01 a.m. to make sure that the 2 servers are in sync. So that's going to stay in place. That's no problem. Now, I'm pretty sure I know which drive is dead, but I'm going to just double check here. So I go to storage. If I go to view disks, DA4 is the one that's dead. So the serial number for DA4, it ends in 9FN4Z. So I'm going to power down the array. I'm going to take out the drive, and we're going to make sure that's the right one, and then we'll replace it. So I'm just going to shut this guy down. Wait a minute, and then we will do the replacement. so give it a minute. All right, while this is going, I'll play a little bit of the video I released today. So if you haven't seen it, the candy set from This Is Hardcore is up. It's probably one of my favorite sets from the fest. I think this is the first year they played, and they got a really great reaction. So if you haven't seen it yet, definitely check it out. I will play a couple minutes from that. Again, while this is powering down, I'll come back in a couple minutes, and we will swap out the drive, replace it with a new one, and be good to go. Actually, I think it's actually powered down. Yeah. Actually, no, we're good to go. We're not going to play the video. We're powered down, so actually I'm just going to jump into it. So I will show you what the array looks like in real life. So all right, hopefully you can see that. One second. I'll adjust the camera. There we go. All right, so again, hopefully you can see what I'm doing here. I'm going to pop this one out. I think it's this one. It's in there kind of hard. There we go. So again, this is what it looks like. Again, this is literally just the hard drive, and these are all filled with them. So what I wanted to check was that this is the drive that died, and I'm checking the serial number here. It ends in 9F N4Z. So this is the one that I want to repair. So that we will replace. So let's just do that real quick. So it's actually the server is really loud. That's like one of the downsides of having this thing in my apartment is it's really fucking loud all the time. So I constantly have to tell people that you kind of got to ignore it. It's sort of it's literally just like white noise for me at a point. All right, here we go. So I don't know what happened to this drive, why it died. What I'm gonna do is there's a chance that it's actually fine, but I didn't want to risk it because I could actually I could tell the system to ignore the error, but my concern is that it actually is a drive failure, and I don't want to have to put the entire array at risk. So I figured, let me buy a new drive. This one, I think the one that I bought was like 130, maybe 130 bucks. So I figured, let me replace it, and then once this is out, I'll plug this into a different computer and then run a bunch of diagnostics. It could be the case that there's some bad sectors that the drive just can't write to anymore, or maybe I don't know, maybe there's something that I could do to repair it. So we'll see. But again, I figured it's best to just replace it now and try fucking with it later. All right. So again, this is the new one. It looks a little different. I guess they changed the stickers a little bit, but they're both WD 400 FYYZs, which is the model that I care about. I'm hoping this is actually brand new. I don't. The static bag that it came in wasn't sealed, so I'm a little concerned that it actually may have been pulled from another system. But I'm gonna make note of this serial number just so I know. All right, so this serial number is. Well, I'm not gonna read it out loud. Not that I think anyone's gonna fucking steal my serial numbers, but I don't think it's that important for me to read this out. So again, what I'm doing is I'm replacing this drive, and then I'm going to pop it back in. I'm going to pop the new drive into the system. I'm going to reboot the array, and I'm going to wipe this drive to make sure that it's ready to go. And then I'm going to let the system rebuild itself. And again, that might take hours or maybe even days for it to rebuild. So I'm just gonna let it do its thing and not stress it out, because the more stress you put on the system while it's running, the more likely it is that you'll have a drive failure. So I do not want to do that. So here we go. We're gonna put these screws back in. So if anyone's watching this, I actually have I have 2 unused 10 terabyte drives for sale. I have an eBay listing. No one's bidding on them. They're basically for roughly what I paid. I think I'm looking for 330 each, which is less than retail. So if you need, if for some reason you need, they're not enterprise drives. They're actually RAID NAS drives, network attached storage drives. But they're Western Digital RAID NAS drives, 10 terabytes each. If you're in the market for them, let me know, because my no one is bidding on them on eBay. So, and I'd like to get rid of them. I guess I could technically keep them just in case the so I'm using those drives in this top one. I could technically keep them for the event of a failure, but again, I've had these enterprise drives since 2015, and this is the first failure, so I'd rather not just sit on drives until I need them. So, all right, what I'm going to do now is just pop this in. Nothing there. Again, like I was saying, these are all empty. So I have 8 of these slots left. It's actually, I should dust this thing while I'm here. Fuck it. All right, I know I should probably be using an anti-static cloth, but it's fine. I'll do a better clean later. But anyway, these 8 are empty. 4, 5, 6, 8. So what I'm going to do in a couple weeks is I'm going to take 8 new drives, put them in here, and I'll create a second volume, and then that'll be everything from 2019 and on. So we're good to go. I've replaced this drive. I'm going to power it on, and hopefully we can log back in and see if it's going to rebuild. So I'll show you what's going on here. So wait a second. So these lights should come on in a second. Maybe not. That's blinking. We'll see. We'll give it a minute. But in the meantime, all right. in the meantime, I'm going to wait for this to reboot, and then we'll check its status. So that's going to take a few minutes. While that's going on, I'm going to play some of this candy set that I was teasing about earlier. Again, if you haven't seen this yet, this is up on the it's up on the page. So I'll play like a minute of that, and then I'll come back and we'll finish up this rebuild.
Losing life. That's what's up, we're Candy. Give it up to Numb playing before us. A long way from home. Help them out. This next one for my demo. It's called Rain in September. that shit up. Trail Rise, King 9, shout out to them. We just recorded an LP, it's gonna be out later this year on Triple B Records. It's called Good to Feel. This next one's called Candy Says.
Take it freely, get it down, say your way.
All right, so hopefully you were watching a little bit of that. Again, that's Candy from This Is Hardcore. The full set is up. It went up today. Looks like we have a bunch more people in the chat. Yeah, so what I've done is I've popped in the new drive. I ran this command, which is again what I ran before, which is zpool status -v, and this is supposed to give me basically an update on what the status of all the drives is. This is still saying it's in a degraded state. It's saying that this drive is unavailable, but I think that's the one that I took out. So I'm kind of wondering whether or not anything's happening. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So let's see. This alert is still telling me that it's in a degraded state, but the drive I added is this one. So the drive is showing up. This is it. So we go to disk. I just want to make sure everything's still running. Let's see. So I'm going to check FreeNAS array rebuild. So I'm just gonna see how other people have done this. Rebuild status. There we go. How to view status of a rebuilding RAID Z in FreeNAS. So that doesn't help. I did run Z. So they're saying just run zpool status and that'll tell you, but what I did. It's not showing me anything. One or more devices cannot be opened. Sufficient replicas exist for the pool to continue functioning in a degraded state. Attach the missing device and online using zpool online. It says see this. So let's check what this is. I have no idea what this is. Alright, so it's saying go to org/msg/zfs-8000-2q. Fault management architecture. Missing device and replicated configuration. A device and replicated configuration cannot be opened. Severity is major. Type is error. Action. All right, so this is saying determine which device failed by looking for faulted device with additional cannot open message. If this device has been inadvertently removed from the system, attach the device and bring it online with zpool online. Oh, okay. If the device is no longer available, the device can be replaced using zpool replace. If the device has been replaced by another disk in the same physical slot, then the device can be replaced using a single argument in the zpool replace command. For an active pool, for an exported pool. Alright, so I think if the device has been replaced by another disk in the same physical slot, which is what I did, I replaced the disk in the same physical slot, then the device can be replaced using a single argument from the zpool command, zpool replace command. So zpool replace. Okay. So let's just try this. Z pool replace. I guess it's just, and then we're gonna paste this. I don't fucking know. No, why does it keep going? Anyway. Z pool replace. Motherfucker, why do you always do that? Alright, so I'm gonna try this. I'm gonna say Z pool replace. No such geom provider, must be full path or shorthand device name. So maybe this. Cannot open no such file or directory. So what's going on? Why? Interesting. All right, I'm gonna do some more research because this is not making any sense. So I'm gonna kill the mic while I do some research, and I'll play some music, see if something to listen to it, rather than me just sitting here clicking the fucking keyboard.
too fucking long. Yo, we're out of merch. We only got smalls, so if you wear a small, I'm sorry. But there's a lot of bands tonight who are a lot more important than us that play tonight. Make some fucking noise for the bands that paved the way for us. Race Trader. Wake of Humanity. For us, this is just sharing the stage with my brothers and some family in front of us. Make sure you support the bands who still keep this shit going. Thank you for walking with us in your home. It means the fucking world to us. Yo, we're gonna keep this shit going. You guys wanna keep it going? Hell yeah! This song is called Enemigo. Don't be afraid to pound the fist and take a fucking swing. Stand your ground. But I'm in at that. Go. This was a bit of a rattlesnake. Take your fucking head.
All right, so I think I figured it out. So what I had to do is I went here. Basically, while that video was playing, I was on YouTube. Literally, I Googled replacing a dead drive in a FreeNAS array. So this guy was walking through it, and I think I figured it out. So what I had to do was I had to go under storage, had to go to the volume, had to click on this guy. This is volume status. And it was showing me the dead drive, or no, it was showing me the new drive, which was, again, it was this, not that. We go here, it was showing me this. So again, if you're running zpool status, this will show you all of the drives and whether they're online, whether it's in a degraded state, whether there are any read, write, or checksum errors. So this is the drive that I replaced, this fourth one here. So I went under here and I saw that as a drive that was unavailable. So I clicked it, and then there was a option to replace. I'm not gonna click it, but I clicked replace, and it gave me an option to select the drive that I just added, which was DA15. And so that's what it's doing now. It's saying the resilver is in progress. So resilver is essentially the rebuilding of the array. So this is gonna take a while. Again, this is in progress. It's 0.04%. It has to do 51 terabytes. So this is going to take a while. So if we go under reporting and go to disk, this should show us, yeah. So basically, we're seeing a peak here in the reads. So things are being read off of these drives. And we'll start seeing, yeah, so DA15, there we go. A lot of stuff's being written to the disk right now. So that seems to me, that means it's working. So again, what it's doing is, it's going through, so again, we have like 15 of these drives. In this case, we have, whoops, we have something like this, and we have one of these drives is dead. And so what it's doing is the system's going through, it's reading all of the data off of the surviving disks, and they're communicating with each other. They're communicating through the RAID controller to figure out what should be in this missing column, basically. And again, as it's figuring it out, it's writing it to the disk. So it's when I say it's resilvering or rebuilding, that's literally what it's doing. It's the drives are communicating, and they're figuring out what data was on this, and how to put it back on here. Again, this is the dead drive, so we're gonna let that run. This is gonna take a while, but again, I wanted to live stream this to document this process, because maybe this will help someone. To show you the viewers sort of more of the tech that goes on behind the scenes here. And yeah, that's about it. So that covers it. Again, if you missed it, today I dropped the Candy video from This Is Hardcore. I'm going to spend the rest of the day working on more videos from This Is Hardcore. I have another one coming up Friday and probably another one on Monday or Tuesday, and I'm going to try to stay on top of it because I want to get this shit done and get it out. So that about covers it. Thanks for tuning in, and I'll see you guys soon.